hello, and thanks everyone for coming to my lecture. Can everybody hear me fine, the last row of the class? Are you hearing me fine, or is it too much, is it too loud? So I can adjust the volume from here, so just let me know. Okay, so as Dr. Colley mentioned, I've been here for the last 1.5 years, and I'm teaching generally on transportation-related classes, and also some of the core classes in our undergraduate curriculum. So today my lecture will be on the effects of information technologies on our lives and how it changes our travel behavior. And is all of this change good? And whether we're being overly optimistic or not. So, okay. So I don't know if you remember the Flintstones and the Jetsons. So I think almost all will know the Flintstones, and for the ones who don't know Jetsons, they are the space age version of the Flintstones. So the Flintstones live in a world where the cars are powered by manpower or animals, and Jetsons live with their space cars, and everything is done by robots, and the technology is super. So they live with all these crazy inventions, basically. So I just put this here because it's a little travel through history. So we actually came from where Flintstones were, but we're not going to where Jetsons are. So some of the inventions that were foreseen in Jetsons, they actually came true, like the face recognition technologies, or you enter the parking garage with your card. So they all came actually true, but they actually missed the point of information. So they never thought about emails. They never thought about the cellular phones or minimization of the computers. So still, George Jetson works with his huge computer. He only presses 1 or 2 buttons to do everything, but still it's huge. He doesn't have like a PDA. He doesn't have a handset. And the letters are still delivered. They're delivered super fast, but they didn't think about emails going around, like all the information being shared. So they actually missed that point. So I just put this here to make you think about how information, the sharing of information and the availability of information really changes our lives, our decision making, the availability of alternatives every day. So I'm going to be talking about transportation as well. So I'm going to be talking about the links in between and how can we use the information technologies to make our transportation system better. So we're always talking about how to make transportation system better, and whenever you talk to someone or listen to some news on the radio or on TV, you hear someone complaining about some issue related to transportation. So what is wrong with our transportation system? So as we all know, the car use is increasing in most urban areas of the world, which is bringing traffic congestion, environmental problems, high fuel consumption, and our growth patterns. So the growth patterns and car use, they actually feed one another. So the problems in one actually causes the problems in the other one. So how can we make our transportation system better? We always talk about congestion. Obviously, there is a lot to talk about the long distances that we're traveling. The distance is getting longer and longer day by day. And also, there is the problem of congestion. Congestion is a system inefficiency. So we are not being able to efficiently move the vehicles from one place to another. It is not only a waste of money, but time that most of us waste in the congested highways. It creates environmental problems, and it wastes fuel, which has links to the concerns about energy. So what does transportation professionals do to solve these problems? So there are 2 ways to look at it, from the supply side or from the demand side. So the transportation people working on the supply side, they try to improve the transportation operations through flow management, traffic signals, ramp meters, and adding physical capacity to roads. And we're going to be talking briefly about them in the later sections of the lecture. And the professionals who are working on the demand side, they try to influence travel demand. They try to influence people's decisions about the travel, such as route choices, mode choices, departure time, their activity participation and scheduling, and I'm going to be coming back to this, their car ownership patterns, and the location choices of their ongoing activities. But in real life, you cannot think about supply and demand separately. They interact with each other significantly, and they both depend on the behavior of the system users. So some of the improvements that you do through operations management, they are going to affect the demand afterwards. And if there are some changes in the demand, they are going to require some supply-side management techniques to take to improve the system efficiency. So the reason why transportation is very complicated and why we're not being able to find exact solutions is we're dealing with humans and they're not predictable. So 2 + 2 is not always 4 in transportation. So people have different preferences, people make decisions, and under the same conditions, not everybody makes the same decision because they have different preferences, they have different lifestyles. And small changes can make significant impacts at the aggregate levels. So you might think, what will happen? It doesn't matter if I change my transportation mode or not. But if it's not only you, but if it's an aggregate number of people who are doing the change, it's going to have an important impact at the overall system characteristics. So we always talk about behavior change is essential, because no matter how you improve the system from the supply side, no matter how much information technology or other technologies that you use, it's the people's decisions in the end who drives the system. It's the people who are using the system, their decisions about the modes, the routes, the location choices, and they're going to affect the system afterwards. So we want behavior change, and we want people to travel less. If they're going to travel, we want them to travel more efficiently, either using public transportation or sharing or car sharing. And we want them to travel green. And the question is, could ICT, the information communication technologies, be the solution? Can we have some technology-assisted behavior change? So to be able to answer this question, I'm going to be talking at the conceptual level a little bit about the travel demand models and some new approaches that are going on in the field right now. So why do we need to forecast travel demand? So what was done before, like 20, 30 years ago, was just observing the traffic patterns, the travel demand, and if there is additional demand, we add another lane. Or if there is additional demand, we add another highway. But this approach is not valid anymore because of the financial constraints, the lack of space, and the environmental considerations. So what we need to do is we need to forecast travel demand, and instead of predict and provide, we need to predict and manage. And to be able to manage this transportation demand, we need to understand how transportation demand happens. This is why the travel models, the travel demand models that we're using should incorporate the realistic representations of human behavior inside them. So this is how the activity-based analysis in transportation came into the scene in the last few decades. And right now, we are shifting from the conventional trip-based models, the conventional four-step model of transportation, to some newer models. And this model sees transportation as a derived demand. So we don't travel for the travel itself, for the sake of traveling, but we travel for participating in activities which are distributed in time and space. Well, obviously, if you just take your car and go for a ride for 10 minutes just for the leisure of it, it's an exception and it's not included in these models. So it's very important to understand the daily schedules of the people, their activity attributes, their choices of their activities, and their implications on travel. Because the observed travel patterns at an urban area is actually the result of the ongoing activity decisions and activity scheduling. So I always give this example when I give like a quick explanation, quick introduction to activity-based approaches. So when you wake up in the morning, you don't think about how many trips you're going to do, but you think about your activities. You think about, well, I'm going to go to school, and from school, I'm going to go and do grocery shopping, and from grocery shopping, I'm going to go stop by my friend's house, and then I'm going to come back home. And travel is the link, linking these activities together. So instead of focusing on individual trips and just counting the number of trips, that's actually what we do in the conventional models, we should be focusing on the daily activity schedules of the individuals. So this is how I see the world works from the activity-based point of view. So the network travel characteristics, like how much time it will take you to go from one place to another, your own characteristics, your social demographics, your economic characteristics, and the opportunities and constraints which are coming from the external environment, they all affect our activity and travel choices. And at the aggregate level, when you sum up the resulting activity and travel agendas of the whole population in an area, it generates the travel demand, and this travel demand in turn affects the network travel characteristics. And in the longer term, it will have effects on the household and individual characteristics and also the external environment. So how do we do this? How do we generate the schedules of people? So probably you can have some ideas about, like, if you want to forecast the number of trips, you can use some of the forecasting methods to just extrapolate the number of trips or use some models to do that. But it's a little complicated when you think about generating the schedules of peoples. So this is why there are activity travel simulation models, and they attempt to replicate the way that people generate their schedules. And obviously there are a lot of areas that still need to be researched and developed, but it's under research right now. So what these models do is, this is an example of how the Florida model works. They get the household survey data, they have the socioeconomic data from the zones, they have the network level of service data, the travel characteristics, they generate synthetic populations. And with these synthetic populations, based on some rules, on the decision rules, they generate activity records for each individual. And the outputs of them will give you how the whole population moves on around an urban area throughout the whole day or whole week. So the advantage of this will be you can actually use some of the transportation demand management policies. You can actually test what happens if there's a congestion pricing. How do you change your route? You're not only going to change your route, but maybe your schedule. So instead of taking the trip at 3 p.m., maybe you're going to make it at 7 p.m. So all your decisions are going to be changing based on some information that you receive. So these are some of the models that are appropriate for testing these these information technologies. What they do is what these models do is they assign some of the fixed and routine activities in your schedule. And we're going to come back to that because these are going to be changing. So for instance, work activities are generally be considered as fixed or routine. And based on the constraints and opportunities that these activities bring into your schedule, the other activities are going to be added together with their travel requirements. So to sum up, the socioeconomic characteristics and external environment affect our activity and travel decisions, which in turn affect one another. And based on these, we have our activity and trip chains. And they affect the transportation network characteristics in the end. And they will have feedback loops to our decisions and also the external environment. If we look at the travel decisions and activity decisions a little more closely, the travel decisions are generally about the timing of your trip. Which mode do you use? Are you going to take transit? Are you going to drive? Which route are you going to take? And nowadays we have another choice whether to do the activity at the location that we are currently, like virtually, because we have that option through the internet, or are we going to physically go there? And then there are these activity decisions about time allocation, the sequencing, how do we put the activity in our schedule, the choice of the activities. So coming back, so actually looking at this, I would like you to remember this slide. Now we want to answer the question, could information communication technologies change our behavior or change the system characteristics, and how? So looking at this, the information communication technologies, if you think about it, they're affecting our activity decisions because the characteristics of the activities are constantly changing. You don't have to go to the banks anymore. You can just do online banking, or you can work from home. It's affecting our travel decisions because you have more information right now. You're more aware of your choices. And they're changing the transportation network characteristics as well. And we're going to see how it happens. So the information communication technologies affect the travel and activity patterns through the operations management, the availability of travel information to the users, and through the changes in our activities and daily patterns. We'll start by talking about the first two first. So looking at the interaction of the transportation network and information technologies, we're going to be talking about the intelligent transportation systems. So I'm sure that most of you heard about ITS, intelligent transportation systems. So these are actually a combination of location, sensing, telecommunication, and automotive technologies for better transportation. And with better transportation, we mean smarter, faster, safer, and more convenient transportation. Some examples could be giving information to the users. If there's an accident on 315, you're going to get information about that, so probably you're going to change your route. Nowadays, there are automated toll collection technologies so that you don't have to go to the toll booths and sit there and wait for the tolls to be collected. Other examples are some more information about travel, knowing your options, in-vehicle systems, the navigation systems that we have that actually show us the shortest route based on time or distance, and advanced travel transit systems that helps the transit agencies to control their operations. So how does intelligent transportation systems work from the system side? So the system, first what's required is collecting data, because you need to know the current system characteristics, analyze the data, and if necessary or applicable, provide solution approaches and communicate this to the system users. For instance, congestion pricing. I'm sure several of you have either went through a road that had congestion pricing, or at least heard about it. So there are several pricing strategies. You can have no pricing at all, which is the base case. You can have static pricing, which is going to be a set price. Let's say it's going to cost you $2 to enter this road from now on. Or you can have reactive pricing, which is going to be a dynamic pricing based on the system congestion level. And it can be also the anticipatory pricing based on the predicted travel on the route. So how does the reactive pricing work? So instead of putting a set price, you change the price dynamically. So you set a price first, and then you apply this toll value to the road. And based on the real-world traffic data, you adjust the toll value. So let's say there is not that much traffic, there is not that much congestion on the road, you can lower the price. Or if you see that it's getting too congested, you can make the price even higher. The objective is keeping the operation at optimum. The anticipatory pricing actually adds one more step to the operation. So you set a price, you apply this price, and get the traffic data, and you predict the traffic in the next planning horizon, which might be an hour, 2 hours from now. And based on the traffic prediction, you apply another toll for the next planning horizon. So this is how it actually works in a flowchart model. So we start with the very top where it says the prediction. So you apply a toll, and then you apply it to the network. Through the sensors, you get the traffic data, what's currently happening with that toll that you set. And you get real-time traffic data from the sensors. And combining it with the historical data and using some advanced traffic models, you actually set up a different toll, or you continue with the toll that you're going with. For instance, this is an example. This might be an example of what we just talked about. So HOT lanes are the high occupancy toll lanes, which are generally used with the HOV lanes. So the HOV lanes are the high occupancy vehicle lanes. If you are 2 or more people in the car, you can use a separate lane, which is hopefully going to be more faster than the other traffic lanes. And at some locations, even if you're a single person in the car, you can use the HOV lane, but then you'll have to pay. So that's why it's called HOT, high occupancy toll lane. And toll rates are sometimes based on the traffic, either through reactive or anticipatory pricing. So let's say in this one, if you're a single person and you want to use the HOT lane, you're going to be paying $1.75. But let's say if the lane gets more and more crowded, through the sensors, the system is going to know about this, and you're going to have to pay a higher price. So the aim is not to make that HOV lane more crowded. And thanks to the radio frequency identification systems, we don't have to go to the toll booths or prepay and get cards or some stickers on our cars to be paying for these. So this is also a technology advancements that makes these things in transportation possible. I talked about the system sensing how many vehicles are passing by and using this information to set the prices. And you might wonder how this is happening. This is happening through the wireless sensor networks. So, and these are getting cheaper and cheaper day by day because technology is becoming more available. So using in-ground sensors with very long battery lives, they provide accurate data for the system. So this is an example from a Census Network's website. So several cities are now using sensors, wireless sensor networks, to get the traffic data and input it into the intelligent transportation management programs. So these were some examples of how the information technologies are affecting the system side of the operation. Obviously, every day there is a new thing coming, and there are several more things going on, but I just wanted to give you a summary about what's going on, and I'll be happy to answer questions if you have after the lecture. So now let's look at the user perspective. What's happening with the users, the humans that are using the system? So everybody has a perception about the transportation system characteristics. And it comes from the real system characteristics and the traveler characteristics, him or herself. And in the end, we make our preferences based on our characteristics and our perceptions. So even if the travel characteristics, the transportation characteristics are the same, we are not making the same decisions because our preferences are different, our own characteristics are different. And how do we know about the system characteristics? How do you know how long will it take you to go home tonight if you're using this route or other routes? So most of the times you have this information based on your experience because you've already traveled along those roads. But in transportation, it's generally your decision. The best decision is not the same all the time. So the decision that you made about your travel choice yesterday might not be the best choice today or even 10 minutes later. So you can use advanced traveler information systems to know about the system characteristics, and they actually affect your perceptions of the system. So what does Advanced Travel Information Systems do? So they provide information to system users. This is what the ATIS does. What are some of the sources of Advanced Travel Information Systems? You can use internet, TV, radio, the signs on the road, which are variable message signs, and your cell phone. So you can use your cell phone. We're getting more and more applications in our cell phones nowadays. You can use them to look up your travel choices, and you can use them for navigation. You can use them for other activities, and also social networks. For instance, there is a company called CitySense, and they're tracing cell phone signals for social networking in San Francisco. So if you're going to go out at night and you want to know which bars are going to be crowded tonight, so you can actually go to their website and check which bars are going to be the most crowded. They're doing this by tracking cell phone signals. And you can even choose the types of bars or types of restaurants that you want to do, so you can actually filter the information. Talking about transportation again, I don't know how many of you have used this trip program that we have on campus. So I know that sometimes it creates errors and sometimes it doesn't give the exact information. But we have this program through the campus transportation services. And if you want to know when is the next bus going to be arriving, you can actually text a message to a number. I don't have the number here. And they will text you back how many minutes you should be waiting. You can do it from your handset. You can do it from internet. You can actually also call them. Well, there are signs as advanced traveler information. So there are signs showing delays ahead. There are signs showing available parking and alternate routes. So these are all effects of information communication technologies that are going to affect your travel decisions. So if there is a congestion ahead, you might actually take the next exit and try to use some of the local roads instead of staying on the highway. Another impact of information communication technologies is making ride sharing more simple. So the old-fashioned ride sharing is probably you know somebody, you know your coworker, you know your friend, you live close to one another, and you decide to carpool to work. But nowadays, many cities are experimenting with real-time carpooling systems. So the people who are going to be the drivers, they offer seats to other travelers with no pre-arrangements. So in these systems, usually the drivers get some sort of compensation so that participate in the program. Although there are a lot of research and conversations going on about this in terms of the role of safety, whether you want to pick up somebody whom you don't really know in your car. But I think this is promising, and with the availability of information and real-time tracking, we are going to have better carpooling systems in the future. So this just summarizes how the advanced traveler information systems, that green box over there, affects our perception and our travel patterns. So to sum up from the system side and from the user side, we have the mobile units and wireless internet, which provides the user-centric views of the system. And then we have the inexpensive wireless sensors at the city level that gives information to the system level about the traffic flows, which creates a whole real-time information. So how does it help achieve our objectives, which our objectives were traveling less, traveling more efficient, and green? We're talking about technology-assisted behavior change here, and there is this question about, is it always good? So there is a lot of research going on, and we don't have a single yes or no answer. And so if you think about it, if the intelligent transportation systems are making travel so easy, is it going to actually increase urban sprawl even more? Because it's very easy for you to get from one place to another. You don't have to wait in traffic. It's going to be so easy for you to pass around accidents and so on. Also, there is another channel of research going on about providing information to users. Is it always good? Because some of the experiments show that if there's an accident on the road, on a large highway, and you let the users know, the users will start using the alternate roads, which are going to be the local roads most of the times. And the local roads are not prepared for such a huge traffic. And the local roads will start getting congested as well. And the research and the experiments show that if the system was let as it was, it would have cleared up much faster. Obviously, we need more research to be done on these, and they might be different from location to location, situation to a situation. But the answer to the question, is it always good, is probably a no right now. So we don't know how we can actually use the information communication technologies for the behavior change that we want. So I just wanted to put an innovation here that I was thinking about when I was a graduate student. So right now we have all this technology, and can we use the cell phone signal tracking to reduce single vehicle occupancy travel to campus? So right now also the Ohio State campus has this program about carpooling. We want to increase the people who carpool, but it's a difficult system and it's difficult to monitor, and you cannot police everyone to obey the rules of the system. It's a very vulnerable system that we have. So can we use signal tracking systems to reduce the single vehicle occupancy travel? So here's Fred coming to campus, driving alone. And the system tracks that there is one person in the car. And now he's coming with his best friend Barney, and the system tracks that there are two people in the car, and this is happening through the cell phone signals, and gives a credit to Fred on his car parking permit. So every time you come to campus with somebody else in your car, you are not the single driver, you get a credit on your parking permit. You get even more credit if you bring more than 2 or 3 people in your car. So these are some of the ideas that people are generating, and I don't know if it is implemented somewhere else or if some people are working on it. I haven't heard as yet, but I thought it was a good idea to start with and use some of the available or coming technologies to give incentives to people for their travel behavior. The last point is talking about the ICT's effects on our activity and travel decisions is through the changes in our daily lives, our schedules and activities. So we talked about the activity and travel decisions in terms of the travel decisions, but there's also the activities that we are doing every day. And the nature of the activities are changing, mainly because of the flexibilities. So some of the activities we used to do before, which were subject to temporal or spatial constraints, are becoming more flexible right now. So for instance, you can work from home, or you can do online banking. You can do several of your shopping activities online. You don't have to travel for all of these. And we're making more dynamic decisions if you compare it to the past years. Because right now we have cell phones. I can call somebody and make a lunch appointment immediately, right? I mean, I don't have to do it the night before and, wait for her to respond, so on. So when we talk about the flexible work arrangements, we are talking about teleworking, which means working from remote locations, or commuting at non-peak hours. So instead of coming to work at, let's say, 8:30, where the whole traffic congestion happens around the highway 315. If you have the flexibility to come to campus at 10, is it a better thing to do? Or leaving also, it also applies for leaving the campus. Either leaving before 4 or after 6, you experience less traffic congestion. So we have all these flexible working arrangements right now. But again, some questions follow. So are we being overly optimistic? So if we assume that everybody will be working from home, are we significantly reducing the number of trips done, or are they being converted to some other trips? So you're saving commuting time, traveling time, and traveling cost, but where is that time and cost going? So is it, so some recent research done shows that people who are telecommuting actually travel longer distances for their social events and for their other leisure and shopping type of trips. So again, this is an area that there is not a yes or no answer, or we are not being able to find what is really going on. And could the availability of telecommuting might affect the residential location choices, and which might even cause more sprawl again? Because if I have the option to telework every day, maybe I might decide to locate myself 30 miles from campus where I can find like a much larger and bigger house for much cheaper. So is it going to cause more sprawl? Are many people going to do this? Because we are not only concerned about, when we look at sprawl, we're not only concerned about the energy use in terms of transportation, but also for the utility distribution. So this is one thing we need to be considering. The other thing is, how does the availability of flexible work options interact with personal and environmental characteristics? Does the location of your workspace mean something? So if your workspace is in a very nice urban place, are you going to be more likely to reject the teleworking option and go to your work? Or if you think about if your work location is somewhere not so nice, then you're going to be more willing to take the teleworking option. And does the urban form matter in these decisions? But the overall most important question is, how are the entire activity and travel patterns affected by temporal and spatial flexibilities in work activities? The examples that I gave you before, your work activities being more flexible, are you going to be spending more time traveling for your leisure activities? This is one of the figures that I showed you before. So your fixed and routine activities are going to be changing because of the effects of information communication technology. So all your schedules are going to be changing. So to sum up, talking about information communication technologies, they are not designed specifically to affect travel behavior. So all the inventions done in terms of computers, handsets, they're not done for the specific purpose of transportation, but they are nevertheless affecting our lives and transportation patterns. And they make travel information available. They interact with operations management, and we're making more dynamic decisions, and our overall lives are changing. This is the first figure that I showed you, and if you look at it, information communication technologies is affecting all of these boxes: the travel demand, travel characteristics, and activity agendas. So if you ask me what is going to happen in the future, well, in this case, it's difficult to forecast the future and how we will change our behavior. So once in 1970s, the chairman of Digital Equipment Corporation said, "I don't understand, there's no reason anyone would want a computer in their home," and see where we are right now. So even those of you who are thinking, well, I don't want a handset with all those abilities inside, I'm not using them, your decisions might be changing pretty soon. And to sum up, coming back to the Jetsons and Flintstones again, so I think we are somewhere in between, but we're not going into the direction of Jetsons. So we have some more going on for us, because we have all this information availability, which is changing our lives much faster than we're expected. So thank you. I think I'm a little early, but